Hello class, this is lesson 6-4 about solving absolute value inequalities. To begin, I want you to recall when we solved absolute value equations, like the absolute value of x is equal to 3. This meant that we were looking for the distance from x back to 0, which would be 3 units. And what values gave us that? Well, it could be 3 or negative 3. So hopefully you remember that. And so now when we have the absolute value of x is less than 3, it means what values of x will the distance be less than 3 units away from 0? So obviously it cannot be 3. It also cannot be negative 3, but it could be possibly 2. That is less than 3 units away. And so I'm going to start shading some of those values that it could be. And notice it's in between negative 3 and positive 3. So this is our compound inequality. And what I want you to notice is that when you have a less than or equal symbol, this is going to be an and inequality. Now when I have the absolute value of x is greater than 3, this means what values are going to give me a distance that's greater than 3 units away from 0. So it cannot equal 3, but it could be 4, it could be 5, 5.5, anything that is greater than 3, but also anything that is less than negative 3. So if I was going to write this compound inequality, I would say x is less than negative 3 or x is greater than positive 3. So a tip is that whenever you see a greater than symbol or greater than or equal to symbol, you're going to think of the word or. So let's go ahead and do some examples now. So we're going to solve and graph the absolute value of x when it is less than or equal to 8. And that's telling us that this is going to be an and compound inequality, which means that the x values are going to be in between negative 8 and positive 8. So I can go ahead and just graph that on my number line, and it's going to be a filled in circle on negative 8 and positive 8, and I'm going to shade everything in between, and that's it. So that was a pretty straightforward one. For the absolute value of v, when it is greater than 2/3, this is telling me it's going to be an or inequality. So I'm going to write down exactly what I have first, that v is greater than 2/3. And then for the opposite, I'm going to flip the inequality and I'm going to make it negative 2/3. So now when I graph my inequality, I'm going to have an open circle at negative 2/3. And I will shade everything that is to the left of that, so everything that is less than negative 2/3. And then I'm also going to have an open circle at positive 2/3, shading everything to the right. So now we have the absolute value of m plus 5 is less than 3. So again, this less than inequality is going to tell us that this is going to be an and statement. So I'm going to rewrite this with m plus 5 in the middle, and I'm going to have it in between negative 3 and positive 3. And now we can solve like we've done before by subtracting 5 in all 3 sections. And negative 3 minus 5 is negative 8, and that's less than m. And 3 minus 5 is negative 2. So there is my compound inequality, and now I can go ahead and graph this on my number line. And since my range just goes from negative 8 to negative 2, I'm going to focus more on the negative side, and I'll have an open circle on both of those values, and I'll shade everything in between. Our next example is the absolute value of 2p minus 9 is greater than or equal to 13. So this already is telling me that it's going to be an or inequality, and so I'm going to rewrite this into 2 different parts. I'm going to copy exactly how it looks. So 2p minus 9 is greater than or equal to 13. And then I'm going to rewrite 2p minus 9 is less than or equal to negative 13. So now to solve, let's go ahead and add 9 to both sides. We're left with 2p is greater than or equal to 22. I can divide both sides by 2, and I find that p is greater than or equal to 11. Same thing for the opposite side. Let's add 9 to both sides. and then 2p is less than or equal to negative 4. And when I divide by 2, I find that p is less than or equal to negative 2. And since this is an or inequality, I should be pointing in opposite directions. So I'm going to just label my numbers there. And I'm going to have my 11 filled in, and it's going to shade everything to the right. And I'm going to have my negative 2 filled in, shading everything to the left. For our next example, because we have a less than, it's telling us that it's going to be an and statement. So I'm going to write everything in between negative 4 and positive 4. And then if I want to get rid of that denominator of 5, that means I'm going to multiply everything by 5. So that's going to leave me with negative 20 is less than 2m plus 4, which is less than positive 20. Now I can subtract all three sections by 4, and that leaves me with negative 24 is less than 2m, which is less than 16. One more step, let's divide everything by 2, and now we have negative 12 is less than m, which is less than 8. And that is easy for me to plot on my number line. So this time I'm going to count by 4, so I'll have my number line just basically going from negative 12 to positive 8. And it's going to have an open circle on both of those values, and I'm going to shade everything in between as possible solutions. All right, our next example is also another less than inequality, which means it's going to be another and statement. So I'm going to rewrite everything to begin with so that it is in between negative 10 and positive 10. And now we can add 2 to all three of our sections. And that leaves us with negative 8 is less than negative 4r, which is less than positive 12. And then I'm going to divide everything by negative 4. But remember, when you divide by a negative number, you have to flip your inequalities. So this is going to be 2 is greater than r, which is greater than negative 3. And I always like writing my compound inequalities from least to greatest, so I'm just going to rewrite this in the reverse order. So now I can go ahead and plot this on my number line, and I'm going to have an open circle at negative 3 and also at positive 2, and I'm going to shade everything in between those two values as possible solutions. And there you have it. So we're going to wrap up with two final examples, but notice this is less than negative 5. And what we learned about absolute value equations is that it could never equal negative 5. In this instance, the distance cannot ever be less than a negative number. So if this occurs, you can stop right there and you can just write no solution. But is it possible for your distance to be greater than or equal to a negative number? Yes, it is. So I'm just going to write that down for you, that it can be greater than a negative. So if this occurs, we're still going to continue on. So I'm looking at the symbol, and this is telling me it's going to be an or inequality. So I'm going to write down exactly how it looks. And then I'm going to flip the inequality and make it positive 5 instead of negative 5. And now I can solve. So I'm going to add 6 to both sides of my inequality. And that leaves me with k is greater than or equal to positive 1. And when I do that again, I find that my opposite inequality is going to give me k is less than or equal to positive 11. So let's go ahead and graph this and see what it looks like. So I'm going to be graphing all of the numbers that are greater than or equal to positive 1 to begin with. So I'm going to just count by 2s on my number line. And I'll fill in my circle at positive 1, and then I'll shade everything to the right, which would be everything that's greater than positive 1. And then I also need to shade everything that is less than or equal to positive 11. So I'm going to have a dot at positive 11, and it's going to go everything to the left. And look at that. they overlap, and it is now showing everything is shaded, which means that all real numbers can be possible solutions for this inequality. So that's what we'll write down. So that's it for our lesson today. I hope that it made sense, but please let me know if you have any questions when you come into class.